Hi, this is Mrs. Miles recording another higher level GCSE question. This particular question has come from Edexcel paper again. If you're doing this topic by topic, it's calculator allowed, and it is trigonometry and Pythagoras. Usually, particularly come the end, the two are together, not always. It's a 5-mark question. It's not right at the end of the paper, this one, okay? It's a fair old way through, but it's not the most difficult one on the paper. Now, the first thing I want to say when you're doing this stuff, and if you're doing higher level, looking at A&A style, you'll know that as well as the normal trigonometry and Pythagoras we think of, you have the sine and the cosine rule. Now remember, if you have right angle triangles, then you're either going to be using your standard trig and your standard Pythagoras. If you've got non-right angle triangles, and we'll come on to this at another time, that's when we'll be talking about the sine and the cosine rule, and if I've taught you before, pairs and sandwiches. Okay, but these are right angle triangles. So least the first line of defence, or the least path, or the path of least resistance, you always try your Pythagoras first, and then your trigonometry, and then that's when you start thinking, is this right angled or not? Okay. Now, what you'll notice is you've got two triangles, okay, connected by this dotted line. We'll talk about why that's significant in a minute. But the first thing I'd always suggest is check that this is on the diagram. So AB is 16, yes. AD is 12, yes. Angle BCD is 40, yes. Angle ADB equals angle CDB is 90. So they're both 90 degrees, okay? You want to calculate the length of CD. So X, if you want to, whatever you want to call it, give it to 3 significant figures. And when I was marking your mocks from before, my lovely year 11s, the things that you were doing this bit right, but when it gets to bits like this, you were losing marks. Don't do that in the exam. So circle that bit first. Okay, so 5-mark question. Now, the reason I talk about this dotted line here is a lot of the time it's very difficult to know where to start. Okay, so if you've got two triangles stuck together, always find the shared length first. Okay, now it's no good me calling that X because that's X. So I'm going to call this bit Y. So what I'm going to do is I'm going to find Y first of all. Okay, now this is a right angle triangle, so the first thing we always try and use is Pythagoras. Now Pythagoras says that A squared plus B squared is C squared. The significant thing is, and some of you will do this different ways, some of you know shortcuts, that's fine, you crack on and do if that's what you use. But C always goes on the longest side, which is always opposite the right angle. A and B can go on either. So I'm going to do this the long way just to, hopefully people understand what's going on. So A and B can go in either place, but they must go on the shorter sides. So if in doubt, sub it in. So I'm going to write Y squared and 12 squared is 16 squared. And so calculator allowed paper, you may not need it. So Y squared and 144, but use it anyway. 16 squared is 256. Oh, I want to mess this up. I'll just check. Yeah, so 256. Now, it's at this point here that a lot of people add these together, okay? But we're trying to find what Y squared is. So we cover it up. So to get rid of that plus 144, we take 144 from both sides. Okay, now I know you can do this without, and hopefully you know that I can as well, but we'll do it to check. We've got the calculator, might as well use it. So it's 112. Now at this point here, when a lot of people again will say that's 112. Now remember, we said this is the longest side. This is where we remember, oh no, Y squared is 112. So to find out what Y is, I square root. Now I'm going to leave it as that. But I am also, well, sorry, I would leave it like that, but I know a lot of you won't like that, so I'm going to write it as a decimal. So root 112 is 10.583. Okay, now the reason I said leave it like that is exact. Root 112, whereas this, okay, unless I keep that in my calculator in the memory function, is going to have to be rounded. So we never round in the middle of a calculation, only at the end. So I'm going to write both down. Okay, if you write enough decimal places, it will be okay in the exam. Okay, but remember they said 3 significant figures. So now I know this bit here is root 112. Okay, this length here. So all this, if you prefer, at the end of the day, you've got to go with what you understand. It's going to make sense to you. So now I know this. Okay, now what I've got here is another right angled triangle. I can't use Pythagoras because to use Pythagoras I need to know 2 lengths to find the other. Okay, like here I knew those and I could find the other. But here I only know 1 length. Okay, so this is where I think, okay, it's got an angle, going to be something probably to do with trigonometry. When we label with trigonometry, we label from the angle. So this, now I'm going to just cross that out a minute, is the opposite because it's opposite the angle. This is still the hypotenuse, opposite the right angle, the longest side. And this is right next to the angle which we call the adjacent. Now when I do trigonometry, I say I want you to circle what you know, okay, and what you want. So what I've circled there is O and H. Now remember your trigonometry, so, ka, toa. Okay, and I'm sure you have all sorts of hideous ways of remembering that. There is no way you're going to catch me repeating those, particularly on YouTube. So I'm going to leave that with you. Okay, now they also use these triangle a bit like speed, distance, time. Okay, where again, if you want to find this, you cover up. But the next step always is to say, right, okay, I've got O and H. Which one contains O and H? Okay, it's this one here. So it's sine, remember not sin, sine theta. Don't freak out about this. This is just a symbol we use to represent an angle. If it bothers you, put like Y or Z or something like that. So sine theta is the opposite over the hypotenuse. You can now use this triangle if you want. Okay, I'm going to carry on doing it the long way just because I think that shows where everything's come from. So if in doubt, sub it in. So I write sine 40, because the angle is 40 and theta represents the angle, is the opposite, which is, I'm going to write root 112. If you want to write 10.583, it's just the same thing, okay, just rounded, over the hypotenuse, which I've called x. Now, at this point here, a lot of people say, oh, okay, I know what to do now, but they forget that this x is at the bottom of the fraction. And this is actually 1 over x, or over x at the moment. I just want x. So, if you're doing this the long way, and I'll show you a quick way in a minute, so that is not an over x, you times both sides by x first. So now you get this. Okay, so now the thing that you're trying to find is at the top, okay, of a fraction. So I've got x sine 40 is root 112. So now, to find out what my x is, I do root 112 over sine 40. So root 112 is there already. I deleted it. Divided by sine 40, and I get 16.464. Now don't forget 3 significant figures. If that was my bank balance, I wish it was as much as that. Okay, but if that was my bank balance, the 3 most important numbers to me are 1, 2, 3. And then look to that next number to decide whether you round it. So that's 6. Remember, 5 or more rounds up. It's going to round that up to a 5. So it's 16.5 centimetres. Now at this point here, it's always good to check that there was nothing mentioned about perimeter or anything else. You don't have to do anything with it. But that is, in essence, the how you do it. Now the reason I'm just going to come back to these as an alternative to get this answer here. Because you were trying to find the hypotenuse, what you could have done is covered up straight away. So this is the alternative, using the triangle. You could have said, right, I'm trying to find the hypotenuse, so I'll cover that bit up. So I've got opposite over the sine part, so sine theta. And if you notice, it's exactly the same as what I've got here. The opposite was root 112. The sine theta bit was sine 40. So use whatever. The reason I use this is because if you forget the triangles, you're in a big old mess. Whereas if you learn the rule, so katoa, you can always sub in, okay, and work from it that way. Okay, but I hope that makes sense. I hope you're all revising hard. I'm sure you are. Okay, and I miss you guys, and I will be here again tomorrow. Take care. Bye-bye.